Hello everyone. My name is Mohamed Mkaouer. I'm an associate professor here at CIT, and obviously this is a CSR seminar. So when I was analyzing my audience, I realized that this is intended for students primarily, right? PhD students or master students, grad students. So I made sure that my talk will not be too technical. At the same time, it will be more informative and geared towards these students, right? So today we're talking about a bunch of research studies that we have done over the years, and this has been done with multiple institutions, primarily with students, RIT, UM-Flint, ETS Montreal, and University of Hawaii. So I recognize those as part of this work. And yeah, I'll walk you through how, as a researcher in software engineering, I have started developing some interest into education as well. Okay. And also I will have another spin during my presentation to talk about how students' perception when it comes to doing such research. So you'll see that hopefully. So that's why I have a lot of slides that I have to go through, and let's get started. So if I show you this piece of code, right, and I ask you to tell me what do you think about it. I ask you to review this piece of code, right, and I give you a spoiler alert saying that it actually works, it passes the test and also does what's intended to do. So it just does whatever it's supposed to, right? So most likely you'll be comfortable with it. You'll be okay with it, right? But if I bring these bad boys into the picture, right, and I start asking those tools to analyze this piece of code, they will start pinpointing a lot of potential issues with the code, right? Things with no pointer exceptions, dead code, variables that are used, wrong type of comparisons, etc., right? So these problems are not necessarily impacting how the code works, right? But actually they make it more prone to errors in the future. Okay. So we are here in the room, a bunch of teachers and students, right? So when we teach our students, or when we learn the good programming practices. Okay. We all teach multiple languages, they all have some rules and some regulations. And we teach the students how to write good code based on a bunch of design principles. You might have known some of these, right? Single responsibility, don't repeat yourself, law of Demeter, which organizes how classes should interact with each other, etc. Right? But any deviation from these good programming practices will unlock another dimension known as the poor programming practices or bad programming practices, code smells, and anti-patterns. Okay, and those are also practices that may not necessarily introduce errors in the code directly, but they will make the code actually more prone to errors in the future. Okay. It's a poor design practices that will make the code actually hard for developers to manage, to understand, to comprehend, and to maintain in the future. And we really know little about it because we don't teach that, right? We just learn this through the fly or through our experience, right? So to introduce some of those famous concepts and popular concepts in industry, let's talk about, for example, the gut class, which is a famous example that a lot of industry has it, which is a class that is known to be abnormally large and monopolizes the behavior of the system and is connected to everything, and it becomes really hard for developers to understand and maintain, right? We also have the concept of misplaced methods, where a method is more interested in the attributes of other classes rather than its own class, right? And this creates a high coupling between two classes, which is unnecessary, right? We also can talk about dead code, duplicate code, lazy classes, shotgun surgeries, and so on, right? And these are known to always introduce, and make the system design more fragile, right? But our system designs are typically nice, right? If I take a look at those, right? So by the book, the idea of fixing all these problems is called, obviously, refactoring, which is the art of changing the essential internal structure of the code to improve how it works. By the way, ask me any questions anytime, so feel free to interrupt me anytime. So our intention is to create those kind of nice designs, right? That's what refactoring is intended. Whenever we think of refactoring, we think of these nice designs. Unfortunately, these diagrams, they exist in our academic books, right? If you look at the real world system, it looks like this, okay? if you want to summarize what this looks like, or what the characteristic of the system, it's actually have a high coupling, it's hard for developers to understand, and it contains a lot of duplicate code. Okay, so existing studies that we have done ourselves to see how developers interact with those systems when it comes to refactoring revealed a lot of challenges, right? For instance, when we work with Xerox about how developers refactor their code, we looked at 171 refactoring pull requests. So let's know what pull request is, right? When you perform it, so in a nutshell, when you perform a code change, you have to go through testing to see whether it's functionally correct or not. And also have to go through code review to see whether it's written in a good way or not, right? So these pull requests are being reviewed by developers. And the intention of these refactorings is to improve the design of the system. So you would expect that developers would accept this way, because this is an improvement of the system, right? It was not the case. Developers and reviewers take longer to approve those changes, despite them being intended to improve the system design. So between a bug fix and refactoring, reviewers will actually pick a bug fix quickly than a refactoring, right? So this becomes a problem. This is counterintuitive for refactoring. Also, when we performed the survey with over 1,000 developers with JetBrains research, we discovered that developers are still shy to do refactoring. They just do it in small pieces, right? Behind the scenes in a manual fashion. Okay. So this is now you understand why our systems are so prone to errors right now, because refactoring is still at its very premature stage. Okay. So that actually summarizes the existing research in refactoring, which can be clustered into 3 different dimensions. How can we detect good opportunities for refactoring? How can we select exactly what code has to be refactored, right? What would be the impact of this refactoring to reduce the side effects and make it more acceptable for reviewers, right? And how can we choose carefully the operations to apply to fix those things, right? So these are the 3 different, areas of research when it comes to refactoring. We have the detection, impact analysis, and actually correction. And this is at the research level, right? But if we ask, and if we decide as researchers to put our feet into the ground, right, and ask this scary question, are these tools adopted in practice? Okay, that becomes a challenge that we have to face, right? There might be a lot of answers to this question. I'm going to pick one of them, right? If you go to Apache Foundation, which is a famous open source bunch of projects that we all use right now, right? We talk about Apache Kafka, Hadoop, Spark, Airflow, Beam, you name it, right? Arrow, etc. So if you look at their issues and pull requests, they are by the magnitude of thousands, right? They have thousands of problems that are dealing with as we speak. This is a recent screenshot, right? So they are dealing with a lot of problems already, which means that these developers are overwhelmed with a lot of things to do, right? They have a lot of responsibilities that they have to deal with. They have so many issues that they have to deal, and that's why they need some sort of prioritization. Okay, so obviously you can see the challenges they're facing. So refactoring becomes another burden that they have to deal with, right? That's a very big problem. Right? So obviously we need better ways to improve and to motivate developers to refactor their code. Okay, so one way for me at least to see it is that we need to also educate students, which are future developers, on how they can refactor their code, efficiently, right? Because once they reach that stage of production, they will be dealing with a lot of other issues, right? So if we also teach them very early how to refactor their code, in the proper way, we can help them in the future do this more efficiently, right? And as we discuss how we can do this, right, we can no longer ignore the elephant in the room. Okay, obviously it came there, right? And now it's changing the landscape of research in so many ways, including, education. Okay, so why should we use language models? Well, because language models they're becoming our best student in the class. That's what studies are saying, right? And I could not, of course, hold myself, but to take this paper, throw it into DALL-E and say, picture this to me, right? And this is also the picture. And I'm like, okay, this is great. And I'm like, wait a minute. I said, by the students in the class, right? Oh, I'm sorry. Here we go. Okay, so so it's going to replace, I guess, everyone, right? So obviously, can we use this bright student to do better with everything, just not refactoring, right? And the answer is actually yes. All the studies that are benchmarking GPT right now, they show that it's good at text summarization, at generation, at debugging, comprehension, elaboration, etc. You name it, right? And basically, all of them are just benchmarking the nature of these language models. And again, a lot of cities are now building upon these language models. And if you want to know why it's so efficient, you may have a lot of answers. One of them could be this, right? Data leakage, right? These models are trained on things that are so known, at least for this case of refactoring or debugging. These models are trained in millions of examples of buggy code that has been fixed. A pairs of bug and a fix, broken code that has been fixed, right? So this gives them a lot of power, right? So, but me as an educator, why should I care? As a researcher, maybe this is interesting to me, but as an educator who is teaching my students, come to class in the morning, teaching programming, why should I care? Well, the answer started back when they first appeared, right? And we had this debate between faculty, which is maybe still happening until now, whether we should ban these models or we should use them, right? Well, I had to really, as a researcher, I have to do just an experiment. Simple. I took my class, split them in two for the exam. So I have two groups. One group has to take the exam in a closed book fashion, and one group has to take the exam in an open book fashion, right? The closed book, they have to just prepare with the whatever they have, the lecture notes, right? And the open book students, they have to use everything, and I emphasize on using language models. So who do you think did better in the exam? Let's do some voting. Since voting is coming up soon, right? Let's practice this already. Who thinks that students with the closed book did better? One. Who thinks two? Who thinks that students with open book did better? Okay, the majority. I have seen that few did not vote. You can do that. Things can go wrong if you do that. You don't vote. So the majority type is open book, and that's also what was my intuition. I will be also voting for the open book. Actually, the results were opposite. Okay, and because of that, I knew something I have to investigate myself. Clearly the results were counterintuitive, which to my understanding, and you can all interpret this because you're all educators here, and you have your own interpretation, which might be correct. My interpretation was misusing those language models is more dangerous than not using them. Okay, that's how I realized I have to integrate them into my classroom. Okay, so I won't steal as an educator to see my students being the brightest in the class and not a language model. Right? Why? Because if we think, the reason why we think that we should ban those models because we are afraid that our students will start just using them for plagiarism or cheating, right? But students, I think they're smarter than that. Why? Because if you, as a student, use this model to replace you for your assignments or your exam, it will replace you now and in the future. So, okay, so, and this is what it is, right? So of course you don't want to be replaced in the future. So therefore you have to know how to use a model and be better than that model. And this is a collective responsibility between teachers and students. Okay. Why I should do this? Because if you look at the number of developers being laid off right now, it's by the hundreds of thousands. So you don't want to be on that bucket. Simple. Okay. So our goal in this is how can we integrate language models into the classroom and help students learn how to do better with software quality. So, okay. So to do this, we have to think about how can we do this in an academic fashion, right? So the way we do refactoring is through multiple, dimensions. We have the deduction, correction, comprehension, and assessment. Let me show you how we typically do this, right? You take your piece of code that may have some issues, you run those tools that tell you where you have to refactor your code. You take a look at it and decide where it's really important. It's all manual work, manual fashion, right? And then you refactor this code, right? So one way to integrate language models will be at the detection level. So it means at this bucket, right? You take this bucket and you replace it with language models, and now they can help you detect those issues because They learn these issues from, millions of GitHub repositories that they were trained on. Okay, that's one way to do it. And then you keep the whole thing together. So students will still have to do all the effort of analyzing those issues and then fix them. Or you can use this for correction. So you run these tools, students will have to prioritize and understand, and then they will have to come up with queries for the model, and then the model fixes issues for them. Or you can use them for comprehension. So you take the code, run these tools, let the model explain and prioritize those issues for the students, and so as they can fix this. Or you can use them for assessment. So students have to do all the work of detecting and correcting the issues and prioritizing them, and then have the language model evaluate to what extent they were successful in doing what they think they should do. Multiple ways, multiple strategies that you have to experience as an educator to do this, right? And you can think of many ways to do this, right? So we did the first, what we have done in our design for our one dimension. We took the students, we teach them again, quality assurance, refactoring, and debugging. We use the models again to detect multiple types of issues, including best practices, coding styles, design, documentation, multi-threading, performance, security, etc. And then we use now language models to evaluate and help the students better refactor their code. Okay. So how they typically do this, it's basically you take the source code. This is where the source code these are the issues of the source code. You may feed this into the language model, right? You give this prompt, say, how can you fix this from me? And you give it the source code. The language model will propose a solution. Students may look at this, change it a little bit, and then they will take it, integrate it back into the source system, run the tools and see to what extent it was fixed. For instance, as you notice here, some of the issues that were here actually were fixed, but not all of them, okay? So let's look at the results, right? Just making sure I look at the timing. Okay, I'm all good. So students used language models to do a variety of things, okay? Fixing issues, going from coding style, design, best practices, etc. Right? What matters to me is that they experience the model into different ways. They learn through this how this model is successful or unsuccessful in situations, right? So that's what is happening here. Also, the students stop working. So just stop working. Here we go. All right. Also, we looked at how long it took the students to resolve these issues using language models. And we discovered that the timing is actually different, right? For some situations, such as documentation and multi-threading and performance, it was pretty much quick. They use it, they get the results, they move on. For problems like design, for instance, they took longer than expected to come up with results, right? Which means they are facing issues and challenges to do that, okay? Design level problems tend to need a lot of context, right? You can think about it because you're looking at the change that happens at the software design level. So you have to have a lot of information fed to the model in order for the model to make the right decision, which is not easy for a student to do, right? Again, you may need some retrieval augmentation techniques that students are not aware of, etc. So therefore, students are experiencing issues and challenging with that, right? And for us, it's on purpose for them to see that. Most purposely, right? Done it that way. Because we want them to know that even when you use these models, it's not always going to give you the right results, right? For instance, 1 out of 5 students experienced issues of regression once they use these models. That means the system, the software that was given or the code was broken. Okay. Students experience a variety of ways to do this prompting, right? Which is also part of us is to teach them different ways of doing prompting without us really doing it, right? They just through the experience they can do this. It's experimental learning, right? And also they end up doing what in literature is known as a zero shot, few shot, one shot. Sometimes students will just take a piece of code and say, hey, fix this for me. Or they will say, I want to fix this, but in this fashion. Or they will say, hey, I made this change myself. This is the broken code. This is a solution. Can you do similar to this one, right? So we've seen this in their own prompts. It means students are learning from their own mistakes, from their model's mistake on how to improve that model. And this is us teaching them or learning them how to use this model in a better way. Okay, so this work was, awarded, the best paper award of how we automate the factoring in the classroom, also how to use language models. And this was, this year in 6E, right? 6E is the ACM Technical Symposium for Computer Science Education, which is the top venue for education. Okay, so this is just to show you an example of how, you can integrate this in the classroom. And this was just for the correction, by the way. So if you have ideas for detection, for comprehension or assessment, let us know. We can do this together. Okay. So, and again, so the idea here is to show the students, how you can, for teachers, you can learn how to integrate this into the classroom, at least for the context of refactoring or software engineering, but also for the students to see how you can take a solution or take a problem and think about a solution first, right? Think about developing a solution, which is, as you can see here, we have more technical details that I skipped, but I want to teach you how we thought about this problem, right? And it sounds easy that you may get a solution that is successful, but actually it's not. It requires a lot of work behind the scenes, okay? So as a student right now, thinking about how can I get my next paper accepted and maybe my next best paper award, how easy or hard this is. How long do I need to do that, right? This is always a question that comes to the mind of students. And today I'm going to shift that mindset from me presenting just a summary of a research into the student perspective, right? To do that, I'm going to introduce you to Anthony Peruma, okay? Anthony Peruma is a student that I had back when I was at RIT. And this is, it keeps freezing. Maybe I can move on to drink water then. Seconds. There we go. So this is Anthony presenting his research topic of his master's degree when he was doing his master's. And that slide explains what exactly he was doing in his master's. This slide may not be clear, so let me bring that to you. It says in his slides, but the objective of my research is to help developers better test their code, right? How can we help developers write better unit tests, right? So that this unit test will be more successful in catching errors. Simple, okay? In the context of Android development, right? So, and eventually he had this picture of moon and stars. So clearly he knew he was shooting for the stars. It's a very hard topic to tackle, right? So again, to give you some context, when you write code, what we've been talking so far is about production code, right? You write your own code for whatever you want to do, right? It has a bunch of methods. So testing code is another piece of code that will be responsible for testing this production code. So from now on, if I production means your code, and then the testing code is the one written for purpose of testing this production to see whether it passes and does what it's supposed to do or not, right? But again, this is also a piece of code, which means by nature it's also prone to bad programming practices. But we have a lot of literature dealing with this, but we have little of idea of what kind of bad programming practices that happen in test code. And that was the idea that Anthony wanted to start with, of how can we improve the quality of test code, right? So Anthony looked at a lot of test cases and came up with this catalog of problems that he thinks are problematic for test code, okay? Let's look at some examples. He looked at, for example, at something called duplicate assert. Means a developer would come and copy paste a test, assert twice. And so this is a test of doing the same thing twice. So what's the purpose of that, right? If you're testing the same thing twice, you just refactor this and remove one of them, right? Because this will not change anything, right? It's actually more lines of code that may be even more confusing, right? We have we've seen cases of empty tests. It means that the developer wrote a test. This test was maybe failing for whatever reason. Because they want the build to pass, they will comment out this test, right? To make this the build pass, and then they forget to uncomment that again, right? So now, if you have this test in the build, whenever developers are testing their code, they think this test is passing, but actually it's not. It's just not even running. So it becomes even misleading for other developers, right? We've seen cases of unknown tests or a test that will be written in a way that does not comply with the excellent guidelines. It says you have to use these kind of methods, assert equal, assert, etc. If you are using them, writing your own logic, this is not a good test. By default, it violates the principle of testing, right? So we built this catalog that is able to detect those situations. And we said these are issues, developers should fix them. Sounds like a good topic. He did that, right? So let's look at the beginnings, right? This idea was born in my software testing and quality assurance class. This wasn't the class. This was Anthony back then, right? This is the picture we take after the class, right? So he decided to keep investigating on those smells, and he made this becomes his master thesis, right? So this is his picture of him finishing his master thesis with this work, right? This is me again with him sitting there taking pictures for credit of a work that, yeah, I helped him with it, right? But just like politicians, right? Taking the credit at the last minute, right? So this work was done again after almost 1 year of him studying this idea in the class, okay? So, and during that presentation, one gentleman, his name is Christian, look at his work. He was in love with the way his performance was, and he gave him a PhD position on the spot. He started his PhD. And that's what happened, right? He started his PhD on a different topic, which is identifier renaming, right? But again, to show you that if you do a good job as a master student or PhD, people will notice that, okay? Clear, this is all good. So now he moved to his new area of research, but we got those results that were promising, and we said, let's just publish this. Sounds like a good plan, right? So we took the results of this catalog, we wrote all these examples, we put them together in a paper, we submit this paper, it got reviewed, it got rejected, okay? We thought that we are unlucky, because we knew this is something that I think was good, so let's do that, right? We submit this again, it got rejected again. We had to revise the paper, we made more, these instructions more clear, we add more examples to make it more appealing, right? It got rejected again. Okay, this is real. Again, we thought, okay, maybe the sample we selected that we showed the examples was maybe too small. Let's make it a larger sample. We did that. We revised the paper, we submitted, it got rejected again. At this stage, right, as a student, you are already doing something else in your career, right? And this paper just keeps getting rejected, right? And this rejection spans from 2017 all the way to 2019. So my question to you right now, as a student, what would you do? Besides crying and going to the bar? I'm sorry?
Archive.
Archive it. Give it up. Give up on it. Or keep trying. But it's not going to work, right? Right? What would you do? It's an interesting situation. Yes.
I would add LLMs or some trends.
Add LLMs. They did not exist back then, right? Unfortunately, maybe, or fortunately. Also, back then, deep learning was a big deal. However, the idea was just those situations, like, I think what we did is we kept digging on why this paper was getting rejected, right? Because there's always a reason that if you pay attention between the lines, you'll figure this out, right? And we discovered that through the reviews, the committee was saying, we're not convinced. This is not convincing. So whatever you think is a problem, we don't say that's a problem. You have to prove this to us, right? So this is a summary of all these reviews. And you know how painful it is to read those reviews. All of us will get rejected papers, right? And it's always painful to read them. But as painful as they are, if you know how to read them, you'll see why this is not funny. Okay? And the reason why it's not funny, simply they were not convinced. So how do you think we should convince the reviewers about this?
Maybe it's a new idea. That's why it was a new idea, and they're not existing literature.
Yeah. But how can we, that's the reason why, because if it was building upon something else, which is published, it will be easier, right? But shall we just drop this idea because it's new, or should we do something that make it more acceptable? So how do we do this? Yes. It was a tool, yeah.
So basically, assess, like, you make like one request or something, assess the multiple screens.
Yes, so if we are promising to, exactly that's what we did. If we are promising that we help developers, then we have to prove that developers accept this. That was the thing, that was the missing piece that we were doing, right? We were saying these are issues for developers, they should fix it, but we never did that. We just come up with these examples and say, yeah, we think this is bad, right? So now we realize that we have to involve developers to see whether they believe these are issues or not. And that's exactly what we have done. We give it one more shot. We look at whether these are really problems or not. So we went online to GitHub. We looked at active projects. We select some of them. We found a lot of these issues, in their test cases. Because we know we can find these commits, we can know who wrote this piece of code, right? So we know the owners of the code. We identified 120 developers who wrote those pieces of code, these unit tests that we are saying they have problems, right? And we contacted them. We say, hey, do you think this is a problem or not? So we get 41 response rate, which is, if you know of the survey, this is a high response rate, by the way, okay? So what developers were saying, this is what they were saying, let's look. It looks like a sloppy coding there. I'll look to fix this or that, right? I have already made this change since you pointed that out. So now the code is cleaner now. I actually have no idea why there is a loop over there that's doing the same thing 1,000 times, okay? There is no point in that, let's remove it, okay? Would not tolerate to have ignored tests in the code, Removed useless example of unit test, and bottom line definitely has this fixed. Okay. Now we have a proof that whatever we're doing is actually useful, right? And makes sense. So we take all these results, we put them back in the paper, right? We wrote these results, we submit, it gets reviewed, and finally it gets accepted. So, right? It was almost 3 years of us thinking about how can we fix this, and finally it got fixed. And this is me and Anthony happily going to the conference to present this work, obviously, right? And since then, we've been talking about this topic, nonstop. Whenever I see Anthony somewhere, I see him talking about this tool everywhere. Okay, so he's become his thing, despite this becoming not really his main research area, but he was always talking about these test smells and test cases because it was his baby, right? And as we did this, we started getting interesting stuff, right? So we're getting this positive impact to the community because we were giving this as a tool as well, right? So we got getting this kind of emails. I'm from this university and I really like this work, please help me make it better. Now you are a PhD student, right? And someone's asking you for help on something that is no longer your main area of focus. You may simply ignore that email, or you may help that student. It's your decision, right? Anthony decided to support the community and help those students, right? He started getting emails like, oh, we made an extension of your tool. And your tool was ugly, so we made a UI for you. And we're just taking this. We loved it. Okay, this is interesting, right? We started getting pull requests. Your code is written in a bad way, I'll fix it for you. And your code does not support macOS, I'll make it macOS compatible for you. We accepted that and we merged it in, right? We started getting emails from industry. We like this thing, it was back in the COVID times, right? Strange times. I'm interested in using this tool. How can we deploy it in our company? And again, we will just keep helping the community. Okay. So as a student, also, you decide to either keep your research publications and papers, which he did, or you can keep also broadening this aspect and engage everyone in this research, right? It's your decision. Okay. So if I had to summarize the story, Anthony went from someone with a lot of rejections, right, into someone who is actually graduating with 466 citations just as a student because of that work, not because of his PhD work. Nobody, knew that now it's better, but back then his test work was the one that made him known in the community, right? So that's how you can look at this work if you keep, supporting the people. And this is Anthony right now at University of Hawaii, teaching his students about testing. And Last week, as I'm standing in front of you right now, I was standing in front of the community who rejected us before, and we get the best paper award for that work. Okay, so a work that has been rejected 7 years ago, after all this time, not only is accepted, but also it was awarded. So it's your decision to take this failure at the beginning, right? Whatever work you do, it might fail so many times and will keep failing until you make it a success. Okay. The story of Anthony is in this length. Now the work that we have done is the de facto for test smells. And I'm happy to share this with you if you want. I can go to this as well. And if you are sitting in this room right now as a student, you are at this level. Okay. So work hard and enjoy the ride. Thank you. Questions? Yes.
I am. It's very interesting to see how the design come into the software,
Yeah.
because this is, but fortunately, you have an entire world that they can see what you do. Like when Toyota builds a car, they just designed it in a lab and they were alone and they were doing it on their own. So it took them to see how the technology improved there. But your case, when you put that out, is available on a web to everyone.
Yes.
So you can get a lot more feedback and figure out how good things are.
Yes.
So it's very interesting. So this is only for computer science.
It's for source code. Yes.
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 My question was, when you give a test to those two group of students, did you try to switch them and see what happened?
Switch.
That means you had two group of students. One of them took it in class
Oh yeah.
and
Yeah.
closed book.
Yeah,
The
yeah.
other used everything.
No. Oh yeah. Yeah. I
Did
see.
they have the same amount of time to take a test? First of all.
Oh yeah. Of course, they had the same amount of time, and I randomly select them. I will, if you do this kind of sampling, they call it sometimes it's better to have two groups that will, more or less have similar kind of qualifications to be accurate. But if we think this test is not accurate, we can always run together in multiple classrooms. We all hit teachers and we can do this together.
Because this is something I'm interested in. I want to
Yeah.
do it in my class.
Sure.
I want to, it's not the coding, but it's
Yeah,
science,
for whatever, yeah.
whatever. To me, the person that uses all the tools available get distracted. also.
Correct, yeah.
And then I should give them both one day to do a test,
Yes.
to come up with because the timing is important when you take a test. So it might be something to look into and see.
True.
I mean,
Yeah, totally. It's an education problem. That's why I thought of LLMs as an education problem from the beginning. Because we don't know how to evaluate students when they use the LLMs, That's
it's just that the test is not a good way to evaluate a student.
No,
Okay.
no. I mean, that's what exactly these conferences are dealing with right now, is how do we now educate and evaluate students' work while they have this in the room? That's the research problem right now. Yeah. That's why for me, from the beginning, I started thinking about this as an education problem because it's impacting my classroom already.
Yes.
Yes, I agree. Yes, right.
While LLM are being used mainly for refactoring, is there any attempt towards improving the security of code algorithm?
Yes, there are studies about how LLMs, there are studies on both sides, studies who look at how can we secure code with LLMs. And I think these studies, what they're doing is they're probably showing, code before and then look at after and see how much of security was improved. And those studies, they get quickly obsolete because after all, these LLMs were trained in a lot of old code, right? And there are studies who look at how not secure the code of LLM is, which also they found a lot of security issues. So yes, there are research on this topic, and I think it's a very interesting topic to be working in because you can always help LLMs make better decisions using your own, because if you know how to do that iterative augmentation, you can quickly help LLM make a better decision when it comes to security, which I think is a very good topic as well.
No, but if it's trained on, unsecure code, what can we go from LLM?
You can fine tune it quickly because you can help secure the code at a larger scale if you know how to fine tune it. It's worth it. It's worth the shot because it has a lot of coding power that we can use right away off the shelf. Again, it's interesting to look at that because we can always train these models into, we have access to a lot of CVEs, right? For instance, I'm just gonna pick the CVE, right? So we know we have millions of examples of vulnerable code that has been patched. We can bring those examples right away and we can start fine-tuning our model towards those examples and see now whether in the future it can be as performant or not. If there are patterns, which I think they are, that we can learn from the past, then we can use them for the new problems. It's a research problem. Whether it works or not, we don't know. That's why it's a very interesting research problem. Yeah. Yes.
Questions for the Zoom.
Yeah.
Does this subject relate to the software architecture class? It's like maybe one of your students asked that.
Yeah, this may be one of my students. Yeah. Yeah, of course, because what we talk about, okay, again, the change if it's at the actual architecture level, then of course it can be looked at the architecture, right? And actually, the challenges that developers are facing are mainly at the design/architecture level. Because if you're changing a piece of code with a few lines in a method, nobody really cares. But if you're going to merge two classes or move one class from one package to another, then you have to get privileges from your manager and higher up, and this is when things become more nested. Yes, that's a perfect question. Yes, it is linked to architectural level changes when it comes to become more challenging.
And what are code smells?
Code smells are bad programming practices, as I explained in the beginning, that will not necessarily create errors right off the shelf because developers will just fix them, but they will make their code more prone to errors at the long run. And you can, of course, find more of these in this link. Examples that shows you how these can manifest. Yeah.
So Mohamed, for the test smells.
Yeah.
Are those generically applicable to all kind of programming source code, programming different paradigms? For example, your Java, that's JU, that's a paradigm.
Yeah. Perfect question.
How about like a declarative program?
Yeah. So let's give this some context. When we started this first, we started with only Android, and then we realized that a lot of these issues are actually language agnostic. Because if you look at this catalog, these issues may exist across multiple, some of them are language specific. Put this up again.
But it's written in JU, right? That's Java.
Yeah. Because we look at, when we have to implement a tool, we have to pick a language. But we realized later that the idea here is actually language agnostic. Because if you look at something like a duplicate assert, this can apply to all languages regardless. If you look at the default test, that's a language specific. Because some languages will create those default tests in the code. Some of them are language agnostic, some of them are language specific. And that's why some companies like JetBrains Research, they took our tool and implemented it in Python. They make a Python version of this tool. Because when you do that, you have to again look at how PyUnit works, which usually XUnit, which means referring to all the guidelines of testing, right? They're pretty much the same across languages. I don't know about the declarative ones. I have not explored that, but I think it's worth also look at that. Why not?
And also, this is a very interesting because the test is now testing is one part of the quality assurance.
Exactly.
Another part of the quality assurance is verification.
Yeah.
Do you know if there's some work going on, let's say, the verification system? So you write the verification code because test will find a problem. Can show that there are problems. Test cannot show there are no problems. A verification tool, once I verify it, is good for all. So,
I see.
So is there any kind of a verification?
I have not seen that not in our community, but I think it's
together. Maybe people can.
Here we go. Then we should talk about that. Then we should definitely talk about that. It's worth taking a look at. Yeah. Yes.
Did you evaluate like the
performance of your tool against coding cloud language models?
Against language models?
Yeah.
No. This is worth doing, by the way. Language models, because they were trained on those that it knows. If you ask what they smell, they will bring those up. Maybe it parsed our website, but I think for these language models would be perfect because the kind of changes we require are very small, right? A lot of these cases are pretty much simple cases, right? Like this one, right? Then this would be a perfect example for a language model. So yes, probably language models will definitely outperform us as long as we keep these definitions pretty much simple. Yeah, that's a good point. Yeah. Thank you. Which means that whether we need our tool or not, we don't know. But we have not tested language models to see what extent they perform, but I guess they will do a good job. Yeah.
There's another button there. I'll just have them unmute themselves.
Sure. Yeah.
Hi, Professor. This is Drew Ferrari from your graduate database design course. I actually just wanted to speak to some of the things that you were talking about here. Can you hear me okay? Yes?
Oh, they can write their tests or their question as well, write their tests. This is why I always tell me students, right?
Professor, are you able to hear me? No.
Well, I think we can hear him, but he put his question in the chat.
Sure.
Are you able to hear me, Professor?
Said, you are the first instructor I've had who has moved past the very basic idea of to allow ChatGPT or not allow. So your presentation has been incredibly useful. As a student in your class now, I've enjoyed how you have incorporated LLMs into the coursework. However, I am wondering if you have implemented a curriculum where you are actively instructing while students provide feedback based on LLM responses. The way you split the different code testing to see seemed a perfect way to work through instruction in real time to improve errors and get students debugging and testing.
I think that's an excellent observation. What I'm doing right now, at least in my class, is, as you know, we are allowed to integrate Canvas into LLMs into Canvas. We have the MGPT, right? So what I did is I trained in one of my classes, not all of them. I took MGPT, which I'm gonna say I recommend, but I think I'm recommending this is because I'm still experiencing this one. I took the MGPT and I trained it on all my previous materials. And I added this to the students. So this way, students can quickly ask questions, right? And see the answer that I need them to know from my materials, right? Because they can find this information also elsewhere, but I wanted to paint this in a very accurate way. And then right now I'm recording those instructions to see to what extent MGPT is useful for the students that way. Okay. I'm also thinking about using MGPT not to assess the students, but to also look at their performance and maybe help them by recommending exercises where they are lacking in my materials. Because I know I have access to their code. I means also MGPT, right? And they can see where they're lacking. That's true. So instead of me giving them the next assignment in a generic fashion, I can now customize my assignment to meet the weak points of the student. That's what I'm doing as we speak. Is I'm trying to experience whether this is going to work or not. And my goal is to see now students spanning or maybe having different assignments depending on their own performance in the class. If it works, you'll see this in the next paper next year. So I'll keep you posted. If you like this idea, also let me know. We can try this together.
I
Yes?
just have a question. So basically, you said you are giving assignments that they are going to like the MGPT and then you are assessing how are they interacting with them?
Yes.
So basically, their answers are generated.
Yeah.
It's not their answers, not their weaknesses, right?
No, I'm looking at how students interact with it, not just to get answers for questions, to get explanations, to look at their own work, to evaluate their own work, because I'm recommending to use in different ways, not just looking for answers.
And
Okay.
for the exam, is it in-person exam or online? For online exams, for example, do you recommend like allow students to use GPT?
Students, I believe that if they know, for instance, right, if they know that this language model has its own limitations, right? They will start knowing when not to ask ChatGPT, or maybe they can come up with an answer and ask it to improve it, which is fine, right? So it's up to the student, because after all, the way they use it is not going to be in my control. It will not be in the company's control as well, right? So that's why I have to keep it that open, right? Is this going to impact their learning curve? Is that your concern?
Yeah, exactly, because I like saw a lot of talks about executive education, and I saw that questioning about raising the bar for exams to make them less and in a way using ChatGPT.
Yeah.
From my personal experience, I gave students to use ChatGPT and I saw the same answer almost everywhere.
Yeah.
And that's when I knew, and it was not related to what I teach them in the class. That's when I knew it's like using ChatGPT, but it was out of the scope. But it's clear when to use ChatGPT, you can clearly identify if a student uses ChatGPT or not. But it's hard to create something that won't be answered, especially in our field. Maybe in other fields it's possible, but in our field, I don't know, do you have any suggestions or communication?
So I think what you have experienced is exactly what I have experienced back in my first experiment, right? And this maybe also ties up to what the professor was saying earlier, I think, about how we are enforcing exams on the students with ChatGPT. Maybe this has to change as well. Because instead of us giving them from A to Z and put them under pressure, and that's when they start using the model in a way that might be misleading, then we have to change the way we do the exams as well.
Yes, that's the thing, raising the bar for the exam.
Raising the bar of maybe not difficulty, but also maybe time.
Yeah, like when international development, it's exactly the same thing, like we had before, they didn't have internet, they used tools and all these things. It's exactly the same thing to adapt the exams to make it harder to, or maybe like create a version of the ChatGPT or customized GPT that basically for this kind of.
Or ask GPT to come up with an exam that they cannot solve. If you want.
So it's not, so it won't be the option.
It wouldn't be a good option. So I think it's us educators, we need to put some effort into this as well. I mean, what you're asking is actually very relevant. And us together, as individuals, we have to think about this carefully and see how we can address these issues. Yeah, this is exactly what brought me to this topic. Because I don't have answers to these questions yet. So yeah, let me know if you want to work on this topic. So. Well, thank you so much, and don't forget to enjoy the food here. So.